Dear students, welcome to today's class. Today I am going to explain a few problems on differentiability of a function which were given in the previous JEE mains examinations. So without wasting your valuable time, so let us start to the first problem. The first problem is given in 2021 mains examination. So the problem is this. Let f of x be a differentiable function at x is equal to a, with f dash of a is equal to 2 and f of a is equal to 4, then the value of limit extends to a, x into f of a minus a into f of x upon x minus a, it is equal to. So options are also available. So first try to understand this problem. So here given f of x is a differentiable function at x is equal to a. What is the meaning of this? So at x is equal to a, it is a differentiable function. That means you can draw a curve at x is equal to a. At x is equal to a, you can draw a tangent to the curve y is equal to f of x. So that is the differentiable function at x is equal to a. F dash of a is equal to 2 means what? You have drawn one tangent no at x is equal to a. The slope of the tangent is 2. That is the meaning of that. F dash of a is equal to 2 means you can able to draw a tangent at x is equal to a. The slope of that tangent is 2. And one more thing, f of a is equal to 4 means its functional value is, this is 4. That is the nature of the curve. So at x is equal to a, the function is differentiable means you can draw a tangent. F dash of a is equal to 2 means the slope of the tangent is 2. F of a is equal to 4 means, so if you substitute x is equal to a in the given function, we don't know that function, the output is 4. Understand this? Okay. So that is the nature of the function, right? Now coming to, we are asked to find out the value of limit extends to a, x into f of a minus a into f of x by x minus a. Right. So generally we proceed like this. Whenever x tends to a means in place of x we will substitute a. So if you substitute a, what happens? You see here, a into f of a minus a into f of a upon a minus a, which is equal to 0 by 0. This is not your answer. Generally whenever such type of indeterminate forms came, we will proceed to, how we will proceed? L'Hospital rule, right? So let us take the L'Hospital rule. So limit extends to a. So here f of a is a constant, x is a variable. So what is the derivative of x? Is 1. That is equal to f of a minus a into, what is the derivative of f of x? It is f dash of x by x minus a, x derivative 1 minus a derivative 0. Now you substitute the value of, so this is equal to f of a minus a into f dash of a. So this implies x is equal to, at x is equal to a given. So here f of a value is given how much? Given f of a value is 4 minus a into f dash of a value is given how much? 2. So on together 4 minus 2a is your answer. Understand? So the option D is the right answer. Very, very easy problem. The only thing you have to do is, so given the problem, you have to completely understand the what is given in the problem. Okay, now, right? I hope that very, very easy problem this is. I hope that you understand this solution. So let us go for next problem. Dear students, welcome to one more problem, right? Let f be any continuous function in the interval 0 to 2 closure bracket and twice differentiable in open bracket 0 comma 2. If f of 0 is equal to 0 and f of 1 is equal to 1 and f of 2 is equal to 2, then, so here options are given. So one of the answer is f dash of x is equal to 0 for some x belongs to 0 to 0 comma 2. So options are very lengthy options are there. So that's why I have not written. So the answer is that f dash of x is equal to 0 for some x belongs to 0 comma 2 open bracket. Then how to do this problem? Okay, first to try to understand this problem. F be a continuous function in 0 to 2, okay, closure bracket 0 to 2 and twice differentiable in open bracket 0 comma 2. That means we can differentiate it in 2 times. It is a function is twice differentiable. That means, so let me draw one graph, a small graph like this. Let us think. So this is a interval from 0 to 2. 0 to 2. See here, see here, f of 0 is equal to 0, f of 1 is equal to 1. So f of 0 is equal to 0, f of 1 means 1, this value is 1. So here 0 is equal to f of 1, and f of 2 is equal to 2, f of 2 is equal to 2. So this is, so it is given that f of 0 is equal to 0, f of 1 is equal to 1, and f of 2 is equal to 2. So now let us check whether, let us break the interval from 0 to 2. So that is equal to 0 to 2, I will break it 0 to 1 and 1 to 2, like that you break the interval. So check in the 0 to 1 and 1 to 1, 0 to 1 and 1 to 2. Okay now. So now there exists, for example, 0 to 0, f of 1 is equal to 1. So this is a 1 and f of 2 is equal to 2. So let us take from 0 to 1, there exists a C1, from 1 to 2, there exists a someone C2. See here, let there exist a C1 belongs to 0 comma 1 such that then how it will be there, such that how it be there. So f dash of C1 is equal to f of 1 minus f of 0 by, so f of 1 minus f of 1 minus f of 0 by, so 1 minus 0 is equal to, see here we know that at f dash of a, the derivative of f dash of a is f of x minus f of a by x minus a. We know the short formula. So their formula, same formula I have applied here. F of 1 value is equal to 1, 1. F of 0 value 0 upon 1 minus 0. This value is 1. So f dash of C1 value is 1. Let us see the, in this example, C2. So let there exist a C2 belongs to 1 comma 2 such that f dash of C2 is equal to f of 2 minus f of 1 by 2 minus 1. F of 2 value is equal to how much? 2 minus f of 1 value is how much? 1 already is given, that is 2 minus 1, that is equal to 1. From this what you say? F dash of C1 is equal to 1, f dash of C2 is equal to 1. That means at a C1 and C2, see here, at a C1 and C2, you can draw the two tangents, at a C2 so that their slopes are equal. At a C1, if you are drawn a tangent, its slope is 1. If at a C2, if you draw a tangent, its slope is 1. That means there exists one point must and should between C1 and C2. Between C1 and C2, there exists a point either in the top and or below. There must exist a point C such that it is differentiable. What is that point? So this point is so f double dash of C is equal to. So what is that point? In the interval C1 and C2. In the interval C1 and C2, C belongs to C1 and C2. So what is the interval? F double dash of C is equal to, right? So f dash of C2 minus f dash of C1 by C2 minus C1. Understand this? F double dash of C2 minus f double dash of C1 by C2. So if it is 1 dash is there, 1 nothing will be there. If double dash of C is equal to f dash of C2 minus f dash of C1 by C2 minus. F dash of C2 value is equal to how much? 1 minus f dash of C1 value is equal to how much? 1 by C2 minus C1 is not equal to 0. Why? Because see here C1 will be there, here C2 will be there. C1 will be in the interval from 0 to 1, C2 will be belongs to the interval 1 to 2. Therefore, definitely they are not equal. Therefore, this is a some one finite quantity. This is equal to 0. So, therefore, what can you say? There exist at least one x belongs to 0 to 2 such that f double dash of x is equal to 0. So, double dash of x is equal to 0 for some x belongs to 0. So, f double dash of x is equal to 0 for some x belongs to 0 comma 2. Okay, na? So, very nice problem, very theoretical problem. So, I hope that you understand this solution. Let us go for next problem. Welcome to the next problem. So, this problem was given in 2011 mains examination. The values of p and q for which the function, so this is a branch wise function or piecewise function. So, when x is less than 0, the function is defined as sin of p plus 1 into x plus sin x upon x. When x is equal to 0, the function is defined as q. When x is greater than 0, the function is defined as root of 1x plus x square minus root x upon x power 3 by 2. Is a continuous for all x in R. It is a continuous. So, that means that x is equal to 0, its left hand side derivative and right hand side derivatives are equal, and that is equal to q. Then what is the value of p and q? So, options are also given. So, there is no very small place is there, and that is why I am not writing the options. Okay. So, very easy problem. We can proceed the problem like so next at x is equal to 0, find out that at x is equal to 0, what is the left hand side limit? So, that is a limit x tends to 0 minus, what is this value? Sin of p plus 1 into x plus sin x by x. So, this is as you substitute x is equal to 0. So, here it is 0, here it is 0, here it is 0, 0 plus 0 by 0, which is a indeterminate form. So, we are getting 0 by 0. This is not your answer. So, let us take the L'Hospital rule. So, this is equal to limit x tends to 0 minus sin x derivative cos of p plus 1 into x, again p plus 1 into x derivative p plus 1 plus sin x derivative cos x whole divided by 1. Now, substitute x is equal to 0. So, if you substitute here 0, cos 0 value is 1, p plus 1, p plus 2. So, what is the left hand side derivative? P plus 2. Coming to right hand side derivative, that is equal to RHL, right hand side derivative, that is equal to limit x tends to 0 plus. What is the value you got here? So, this is equal to root of x plus x square minus root x by x power 3 by 2. So, you can easily before doing this problem, you can easily do this problem by taking the it is also in the form of 0 by 0 form. So, you can take the L'Hospital rule. So, that is equal to root of x. Before going that, multiply the numerator and the denominator with root of x plus x square plus root x. So, in the numerator you will get, so this is equal to limit x tends to 0 plus x square minus x upon x power 3 by 2 into root of x plus x square plus root x. Okay, now, right. See here plus x minus x will get cancelled, x square upon x power 3 by 2. So, this is equal to limit x tends to 0 plus limit x tends to here 2 minus 3 by 2. So, 2 minus 3 by 2, that is equal to a power m by a power m minus n. So, 2 minus 3 by 2 is equal to 2's are 4, 4 minus 3, 1 by 2. That means root x depend upon. Denominator also you can take root x common outside. So, if you take root x common outside, so it will be written as 1 plus x plus 1, you can write it as. So, you can check it. Okay. So, you can cancel root x and root x. So, x tends to 0. Substitute here 1 by 2. Okay, now. So, left hand side derivative, right hand side both are derivative. Why he is saying that continuous for all x in R. That means what is the left hand side derivative here? P plus 2 is equal to 1 by 2. P is equal to 1 by 2 minus 2. So this value is given as minus 3 by 2. P value is minus 3 by 2. Q value 1 by 2. Why? Because see here at x is equal to 0, f of x value is equal to q, no? So that's why their limit value is also equal. That is equal to p value is equal to how much? 1 by 2. So p value is minus 3 by 2, q value 1 by 2. So very nice problem, very easy problem this is. So I need nothing difficulty in it, this problem, okay. So I hope that you understand this solution. So let us go for next problem. Welcome to the next problem. The next problem is f of x is equal to x cube, where x square is less than 1. When x square is greater than or equal to 1, f of x is defined as x, that is a straight line. Then the set of values of x when f of x is differentiable. When f of x is differentiable. So here we have to say that set of values means here some intervals are given, options A, B, C, D. So in which interval? Minus infinity to plus infinity, or minus infinity to some 1 and 1 to like that. So where it is not differentiable, let us check that. So this type of problems can be solved easily using graph. First try to understand why, because here y is equal to x cube, y is equal to x. Both graphs are very easily to draw. Very easy to draw. Understand that. So when x square less than 1 means what? X square less than 1 means what? X square less than 1 means x square minus 1 less than 0. That means x plus 1 into x minus 1 less than 0. That means what? When x lies between minus 1 and plus 1, so your graph is x cube. X square greater than or equal to 1 what? So here your graph is x cube. Here and here your graph is x. That is the idea to draw the graph. From minus 1 to 1, the function is defined as x cube. From 1 to plus infinity, from minus 1 to left side minus infinity, the graph is defined as x. Understand this. Now let us try to draw the graph. Right. So this is equal to x-axis and it is y-axis. So this is a minus 1, this is plus 1. From minus 1 to plus 1, the graph is, so this is equal to minus 1 to plus 1. The graph is cubic equation, y is equal to x cube. Y is equal to x cube. Understand? Except 1, the graph is x. X is means what? A straight line. Straight line passing through, not passing through origin. So this is a straight line. So this is the graph of the given function. The function is defined like this. So from minus 1 to 1, the function is y is equal to x cube. From x greater than or equal to plus infinity and x less than minus infinity, these are the graphs. So it is a very just by observation you can say that this is not differentiable at x is equal to 1, x is equal to minus 1. Why? Because if you find out here a left hand side derivative and right hand side LHD value is not equal to RHD value. Here also LHD value will not be equal to RHD value just by seeing one way, because there is a sharp edge there. So therefore at those 2 points the function is not differentiable. So what will be your answer? So your function will be differentiable. The function will be differentiable at minus infinity to plus infinity except minus 1 and 1. Except at minus 1 and 1. At these 2 points the function is not differentiable, and remaining all points the function is differentiable. Okay na? I hope that you understand this solution. So let us go for next problem. Welcome to this problem. Here f of x is equal to, the function is defined as f of x is equal to modulus of 1 minus 4x square when 0 less than or equal to x less than or equal to 1. So that means where x values lies between 0 and 1, the function is defined as modulus of 1 minus 4x square. When 1 to 2, when your function lies between 1 to 2, your function is defined as greatest integer function x square minus 2x, where the step function x square minus 2x is the greatest integer function, then f of x is. Then is it differentiable for all x, continuous at x is equal to 1, non-differentiable at x is equal to 1, none. So this problem also can be solved easily using the graph. Now first take this graph, modulus of 4 minus x square. 4 minus x square means that the critical point is 1 by 2. Critical point means what? Turning point. Turning point. So if at x is equal to 1 by 2, see here 1 by 4, 4 cancel, 1 minus 1 is equal to 0. So at x is equal to 1 by 2, the graph takes the turning. That's why, so you divide the interval into 0. So your f of x is defined as, so first I am taking this function, okay now. So when your 0 less than or equal to x less than or equal to 1 by 2. So where x value lies between 0 and 1 by 2, let us see what happens. From 0 and 1 by 2, let us take any one value. Let us take 1 by 4, not 1 by 4. If you take, we are going to check whether 1 minus 4x square is a positive or negative. So let us take any one value. So 0 point, you can take from 0 to 1 by 2, you can take 1 by 4, you can take 1 by 5 also you can take 1 by 5. So you take this 1 minus 4 into 1 by 5 is 1 by 25. So 25 minus 4 by, so it is something positive. You will get a positive value. Therefore, so 1 my modulus of 1 minus 4x square when x greater than 0 means same thing you will get, that is 1 minus 4x square. When 1 less than or equal to x, 1 by 2 less than x less than 1. So your x value from 1 by 2 to 1, obviously it will be greater than 0. So this will be, so this is equal to less than 0. 4x square minus 1, it will be less than 0. So this is the graph of your function. For this we can draw the graph. Now coming to this modulus function, it should be very, very critical. See here how to do this. Okay. So this is equal to 1 less than or equal to x less than or equal to, this means 0 less than or equal to x minus 1 less than or equal to 1. That means your x minus 1 lies between 0 and 1. That means I have subtracted 1 on either side. Now coming to your modulus x square minus 2x. This can I write down x minus 1 whole square minus 1. Otherwise is minus 1. X square minus 2x plus 1 minus 1 will get cancelled. This is equal to, we have one property, that is x minus 1 whole square minus 1. So this is step of x minus 1 whole square minus 1. If it is an integer, we can write that integer outside. Up to here, what is your value? X minus 1 whole square value is equal to how much? See here, your x minus 1 lies between 0 and 1. 0 and 1. Therefore, x minus 1 whole square is also lies between 0 and 1. What is the step of the any number which lies between 0 and 1? That is 0. 0 minus 1, that is equal to minus 1. So for all, whichever may be the value which lies between 1 and 2, what is the value of x square? Step of x square minus 2x is equal to how much? Minus 1. Understand this? So using this and this concept, we are going to draw a graph, and using that graph we can decide whether the function is continuous or differentiable, or where it is continuous, where it is not continuous. Let us continue our solution. Welcome back to the solution. So here, as from 0 to 1 by 2, the graph is like this down, and 1 by 2 to 1, the graph will be here 1, here 1 will be there, the graph will be like this. So this is a modulus of, so it will continue like this, it will be continue. Okay, this is the modulus of 4 minus x square graph. Coming to the step of x square minus 2x graph, so this is what we got, minus 1 for all x. That means whatever may be the x, from 1 minus 1 to it will come and it will break. So coming to your options, differentiable for all x are not at all. Why? Because there is a break here, break is there. Continuous at x are, no, it is not, it is not. Non-differentiable at x is equal to 1. Yes, at x is equal to 1, this graph has break. The graph has the break. So this is called non-differentiable at x is equal to 1. Therefore, option C is the correct answer. So dear students, such type of problems are very important using graph, and by analytically, creatively if you observe, you will get the answer solution very easily. Okay na? So dear students, I hope that you enjoyed today's class with some more problems and some more concepts. In the tomorrow's class, I will stand before you. Until then, all the best.